I'll use a real attack as a case study to demonstrate the concept. This is a simplified real case. So it's just to illustrate the concept. So I took out some of the details. So on the left side is what a normal user interacts with that smart contract. Essentially, this is a deposit some tokens on chain 1, and then withdraw a different tokens, but with the same value on chain 2. Okay. So the user first interact with the chain with the smart contract on Solana side is that they send a verified signature and associated payload. Payload is really a fancy word for the value of the token. Then you post that signature and payload with that smart contract. Then you transfer the payload. So it's 3 steps. Easy. That's when things are normal. What the monitor can learn from that, as the monitor keeps learning from that transactions, first, it learns, even without the source code. Okay? So when users supply that instruction, the force account, it should always point to a system account. Okay? And then the payload amount should match the other chain. Because if you deposit X in the other chain, you should only be able to withdraw same value on Solana. Third, even though this is a weaker invariant that we have learned over the transaction period, maximum payload is less than 1,000. Okay. And then in a real attack, what happens? Attacker actually supply the instruction, replace that system account pointer, and point to a smart contract the attacker launched. So in each of those steps, the monitor finds now the force account does not point to a system account anymore. That's a big no-no. That's a red flag. And then the value submitted does not match the other chain anymore. That's another red flag. If you wasn't sure in the first step, I think by now you should be very sure something's happening. You should do something about it. And then there's another, even though it's a weaker one, that the instruction submitted was to withdraw more than 100,000. That's a 2 degree of magnitude bigger. I'll do a small demo. This is a replay of the actual transaction. Okay? So the setup of the demo is that we'll play 100 transactions right before the attack happened. Okay? And our monitor in the background continues to learn about the environment. So set up the monitor system. Then when the attack actually happens, the system will alert you. There will be 3 alerts, each highlighted in red color. We intentionally made the font so small, so I wouldn't be able to see anything. I'm sure you are able to see everything. So you just have to trust my words of it. So the transaction gets played. There's 100 transactions. It's fast forwarding. And then the system starts learning. The system actually learned more invariants than the 3 invariants I talked about. Okay? And then that's the first alert. That's when the hacker supplied in their input a different pointer than the system program. This is the second one. This is the third one. Apply the same concept along the same way. We can build a lot more customized monitoring. In Saxray, we call it bots to do different things. In my mind, essentially, it's taking in data, apply certain domain knowledge. In our case, it's security domain knowledge. And then process the data, extract useful information, and use that information to do something. We encourage the community to work with us, that we're just starting on this, and we'd like to hear from you what you'd like us to build for you.